Hello everyone, welcome to today's video. So in today's video, we'll be solving the problem find first and last position of element in sorted array. Alright, so this is a medium level question and has been asked by 8 companies, and some of them are Amazon, Flipkart, and as well as Facebook, Microsoft as well. Alright, so what does the question state? So given an array of integer nums sorted in non-decreasing order, find the starting and ending position of a given target value. And if target is not found in the array, return -1, -1. So you must write an algorithm with O of log n runtime complexity. So what are the things that we need to understand from this question? The very first thing that we need to understand is that the nums has been sorted in non-decreasing order. The array that has been given to us, the elements in the array are sorted in non-decreasing order. What do I mean by non-decreasing order? Take any element in the array. Alright, take any element in the array. All the elements to the right of that element will be greater than or equal to it. So let us take 7. Alright. So considering the first 7, whatever element that you take to the right of the 7, you'll find that element to be greater than or equal to 7. So there is an 7 to the right of the 7 and all the other elements are greater than 7. So that's what it's meant by when you particularly say non-decreasing order. All right, so that is the first thing. And second one, they are expecting us to write an algorithm with O of log n runtime complexity. Once we see something like this, O of log n, the very first approach that we need to work on is binary search. All right, and also the nums or the array that has been given to us is already sorted. So binary search is the most optimal solution and the possible solution to this question. So let us just understand this with help of some examples. So very first example, let me write this here. So I'll be using the white ink. So 5, 7, 7, 8, 8, 10, and they're asking us to work on the target 8. Okay, target 8. So this is my first example. So 8 comes at the very first third index. All right, third index, and the last appearance of it is the fourth index. So the answer that we're going to return is 3, 4. All right, so let us take another example. So same example, 5, 7, 7, 8, 8, 10, and if they're asking us to find the target value as 9. So there is no appearance of 9, right? So there is no appearance of 9. We do not have 9 in the array. So the very first appearance and the last appearance doesn't make any sense. So we'll be returning -1, -1. So there is another case, like you people might be having this case in your mind. 5, 7, 7, 8, 8, 9, 10. Okay. Now they have asked us to find the target value of 9. And if you would have seen the examples, there are like 8 is repeating for twice, right? 8 is repeating for twice, and they have asked for the first and last appearance. So we have given the answer as 3, 4. But what about this? 9 is only appearing for once. So what is the answer for this? The first appearance and the last appearance is on the same index. So we'll be returning the index as the same thing for both of them. So what is the index? So this is 0, first, 2, 3, 4, 5. So we'll be returning the answer as 5, 5. Okay, so this is the answer that we're going to return. If the element is not there in the array, we'll be returning -1, -1. If there is an element and if there are more than one appearance in the array, then we'll be returning the first and the last. And if there is only one appearance in the array, we'll be returning the same index as the first appearance and the last appearance. So this is how it works. So I hope you people understood what should we actually return to the answer, to the function. So even in the constraints, so the nums length is going to 10^5. So some of you might be looking out for some other O of n square or something, but that doesn't work out, and it's not really needed because the array that has been given to us is already been sorted. So it's a non-decreasing array. All right, so that's what we need to look for. And how do we proceed? So as I told, so the only approach to this optimal approach is binary search. All right, so binary search. So what do I mean by binary search? So there are two ways to apply the binary search to this. write the algorithm, binary search, write the algorithm and find out the values. All right, you can write the binary search algorithm and find the first appearance and the last appearance and then just return it. If you do not find anything, then you return -1. But there is an other approach, like how do you write it, or how do you write the code. So we'll be using the STLs. Okay, we'll be using the STL. What are the STL that we are going to use? First one is lower bound. Okay, so this is what we're going to use. Second one is upper bound. So how do we use this? So remember, things to be remembered are these two functions, these two STL work on binary approach, binary search itself. All right, internally they implement the same thing, binary search. All right, so how do we use it? So let me go to the panel first. So remember, lower bound and upper bound. All right, lower bound and upper bound returns these are of the type. So first is let me write this in a points wise. First point is they are implemented under binary search. All right, fine. So they use the same algorithm, binary search algorithm. And second one, they are address data types. All right, they are the data type. So address data type. All right, so how do we make use of this? So let us write this first. So I'll be using auto it. Okay, auto it low is equal to lower bound of nums.begin nums.end target. So what do I mean by this? So auto it low is lower bound of nums.begin nums.end target. So when I write this, I ask that, so let us take this array itself, 5 7 7 8 8 9 10. Okay, and I'll be naming this array as nums. And now if I apply, like, and also the target is 8. Okay, so target is 8. So once I write lower bound of nums.begin nums.end and target, that is 8. So the answer that I'm going to get is the address of this value. This is nothing but the address of this value. So what do you mean by lower bound? Lower bound gives the address or the pointer to that element which is just equal to the target that has been given to the lower bound. So here we have mentioned 8, so it will be going to this address. All right, so this point, this address. And once if I use star to this lower bound, okay, star to the lower bound, I'll be getting the exact value that is there at that address. So this is nothing but 8 itself. All right, so star of lower bound nums.begin nums.end 8 points to this particular place. Let us assume that 8 is not there. Okay, let us assume the 8 is not there over here and we are looking out for the element like 8. So then what do we actually get? Then it will be pointing out to the 9. All right, then it will be pointing out to the 9, because let us assume this, both of them are not there. 8 and 8, both of them are not there. And now I'm trying to use the lower bound nums.begin nums.end 8, then it will be pointing out to 9. That means it will just point to that element if it is there, if the target is there. If not, it will point to that element which is just above or just greater than the target that we are working on or looking out for. All right, so it will be pointing out to this. So I'll be doing this auto it low is equal to lower bound nums.begin nums.end target. And now I'll see if your it low star it low is not equal to the target. Okay, or there is another case like it low is equal to nums.end. all right, so both of these cases might happen. What do I mean by nums.end? So let us assume the array is 5 7 7 5 7 7 7. Okay, and we are looking out for the target 8. All right, we are looking for the target 8. There is no element that is 8 in the nums, and there is no element that is just greater than 8. So my lower bound will be pointing out to this. Okay, nums dot n. So it will be pointing out to this. And now that is the reason, if my lower bound is actually pointing to the end of the nums, that means I do not find the target. Alright, so you must understand this, that if your lower bound is actually pointing to the end of the nums, that means you do not have the particular value, or the any value that is just greater than that particular value. So because there is no 9 in this, no 8, no 9, so that is the reason it's pointing out to the nums end. Okay, nums end. Like if I just say this, like no element that is greater than 8, no element that is greater than 8, no element that is equal to it, that is the reason it's pointing out to the end of the nums. So in both of these cases, I can say that my particular element is not found, so I'll be returning -1 comma -1. All right, so -1 comma -1. If in case this is not actually going to the if loop, that means we have got that particular index. So now I'll be doing auto it of up is equal to upper bound of nums dot begin comma nums dot end comma target. So what do we mean by upper bound? So auto upper bound is, so we have learned about the lower bound. Now upper bound, coming to the upper bound, so I'll just erase this stuff. Coming to this upper bound, we'll be doing the same thing, like we are working under, like it's working under, being implemented under binary search itself, and even that address of it's of data, like data type is of address. Okay, data type is of address, but the thing is, lower bound points to that element, like it points to that element which is greater than equal to the target. All right, lower bound does this, but coming to the upper bound, it points to that element, which is strictly greater than target. All right, strictly greater than target, it will point to that element which is strictly greater than target. For example, we'll be taking the array, same array, nums equal to 5 7 7 8 8 9 and 10, or let us assume we'll not take 9, we'll just put it 10. All right, and my target is 8. So the moment I write upper bound nums dot begin nums dot end and the target 8, I would be getting this like this would be pointing to 10, because this is the only element that is just greater than 8. So it will be pointing to this particular 10 address. So when I just put them, at the moment I put star, I'll be getting this value as 10, because the element that is just greater than the target that I'm looking is 8. I'm sorry, 10. So it is, this is what it will be pointing to. So I'll be doing auto it up equal to upper bound nums dot begin comma nums dot end comma target. Now because it points to this particular thing, but I want this, right? Because I want to find the last occurrence. I do not want to find that element that is just greater than this. Rather, I wanted to find that last occurrence of the target that I'm looking for. So if I just subtract this iterator, so all right, because it is pointing to this, what if I just subtract it? Then it will be pointing to this, right? So let us assume this is it. Okay, so the moment I write it minus minus, it will be pointing to this particular value. All right, so that is what I'll be doing here. I'll be doing it up minus minus. All right, so once I do this, my iterator will be now pointing to this particular element. Now I want the indices of those. So int low would be nothing but it low minus nums dot begin, and up is it up minus nums dot begin. So what did I do here? So nums dot begin is basically nothing but this 0th element address, right? So my it, so I'll just erase this. So keeping this target as the same value, all right, keeping the target as 8, my it low is currently pointing here, right? It low is currently pointing here. IT up is currently pointing here, right? So initially IT10 is this, IT up is pointing to this, once I do minus minus, I'll be pointing it to this. IT low is this and IT up is this. Now nums dot begin. This is nums dot begin. Nums dot begin. So I want the index, right? Index of this IT element, IT low element. So I'll be just subtracting IT low minus nums dot begin. Okay, nums dot begin. Once I do this, I'll be getting this particular element address. IT up minus nums dot begin will be getting this particular element index. That's it. So and now we'll be returning this array, return low up. That's it. I hope you people understood what are we trying to do. So these are the addresses and this is the base address. So once we subtract, we'll be getting the length in between, that is 3. And once we subtract, we'll be getting the length is between these 3, that is 4. All right. So 0 index, first index, second index, third index, and this is fourth index. That is what we'll be getting. So let us run this array, run this solution first. It must hopefully work out. Yes, it worked out, and let us submit now. Yeah, it got accepted. I hope you people understood this. So basically we are working on two things, lower bound and upper bound, and things to remember that they are working under the implementation of binary search itself, and there are the data types of addresses like they're iterators type, and the point to the, lower bound points to that element that is greater than or equal to the target, and upper bound points to that element that is strictly greater than target. So these are the two things, and using this we are able to figure out the solution to this. And the time complexity is O of log n itself, because very important point to remember, they are working under the binary search implementation itself. Okay, so these are the things, and I hope it made some sense to you people. So if there's any doubt or something, you can feel free to comment that out. I'll be happy to respond to you. So the important aspects that need to be taken out after of this session is lower bound and upper bound and their significance. All right, thank you for watching this video. Stay tuned.